Now that we've gotten a little bit of practice with how to factor using the factoring by grouping method, I'm going to show you two shortcuts. The thing that you have to be the most careful about is you have to know when you're allowed to use them, because there's only two special kinds of quadratics, which are the squared kind of polynomials, that we're allowed to use these shortcuts on. So not only can you know the shortcut, but you have to know when you're allowed to use it. Now, the first shortcut, some of you may have already noticed, and that is what happens when A is equal to 1. So what happens when A is equal to 1 is that the side numbers from the diamond end up being the numbers that go into your factors, so you don't have to do any extra work. So for number 18, let me show you the way that we would have done this before, and then on number 19, I'll show you how we can save some time. So what we would do is we would set up our diamond with A times C, and you can see here A is 1. That's what we're looking for this shortcut. So 1 times 16 would be 16, and B is negative 10. The numbers that would give us that would be negative 2 and negative 8. So we would do our x's out, x's in. So I would take out the negative 10x, and I would put minus 2x minus 8x plus 16. I'll split it in half and take out my GCFs. So I get x minus 2. Oops, this should be a 6. Then I can take out minus 8, and that also gives me x minus 2. So you see my factors are x minus 8 and x minus 2. Here's the shortcut. Do you see how I had a negative 2 on my diamond, and now I have an x minus 2 in my factor? I had a negative 8 in my diamond. Now I have a minus 8 in my factor. And so that is the shortcut. Really what we can do is we can go ahead and skip all of this and go straight to our factors from these two numbers in our diamond. Again, I can't stress enough, the most important thing about this, you are only allowed to use this shortcut when there is a 1 in front of the x squared. So let's look at number 19 and see if we can do that a little bit faster. So A is equal to 1. That's what we're looking for. So I set up my diamond. 1 times negative 30 is negative 30. Positive 7 goes on the bottom. So we need to think of what multiplies to negative 30 and adds to positive 7. So that would be 10 and negative 3. Now the shortcut is to skip all the grouping, and we're going to go straight to our factors. They're both going to get an x in front. And then I'm just going to put in the two numbers. Positive 10 makes a plus 10. Negative 3 makes a minus 3. And so there's our factors. If this were 2x squared plus 7x minus 30, then the shortcut does not work. It only works when A is equal to 1. Now, the second shortcut is a little bit more difficult to follow. Remember, we've seen the ones where there was only two terms, and so B was equal to 0. This doesn't work for every single one of those cases, but this is called a difference of two squares. Now, the most important part here is this word difference. Difference represents subtraction. So it must be a subtraction problem. If it's addition, this doesn't work. And when we talk about squares, we're talking about perfect square numbers. So hopefully you recognize some of your perfect squares. Let's list out the perfect squares from 1 to 15 just to see what we've got. So this comes from 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. I'm going to go ahead and list the rest out. 36, 49, 64, 81, 100. That gets us up to 10 squared. 11 squared is 121, 12 squared is 144, 13 squared is 169, 14 squared is 196, and 15 squared is 225. I highly doubt you would see anything bigger than that. Now, here is the rule for the difference of squares. This is why it saves us a little bit of time. If I have two perfect squares with subtraction in the middle, then whatever I'm squaring, that becomes our A and B, and the factors just become A plus B and A minus B. Now, this is a little bit harder to see, so let me show you one here. when I have 9x squared minus 49, you notice if you look up your list at perfect squares, 9 and 49 are both perfect squares. So we have to ask ourselves, what did we square to get 9? And that was 3. And what did we square to get x squared? Well, we squared x. So this is 3x squared minus, what did we square to get 49? That's 7. So this is really 3x squared minus 7 squared. So we look at this, 3x is our A, 7 is our B. We're going to use those two things, 3x and 7, in both factors. But what we do is one gets a plus and one gets a minus. And so there are our two factors. That's all there is to it. So go ahead and look at number 21. See if you can think about what it is that we're squaring to get each of these. The first thing I notice is that I have subtraction. That's good. And 16 and 25 are both in my list. And then my x is squared and my y is squared. So these are definitely perfect squares. This would be 4x that we're squaring minus, this one would be 5y that we're squaring. And so 4x is our A, 5y is our B. That means our factors would be 4x plus 5y and 4x minus 5y. And that's it. You don't have to set it up with a 0. Now don't forget, if you just have an x squared by itself, like let's say I have x squared minus 9, x squared by itself is a perfect square because this is just x to the second power. Then this would be minus 3 to the second power. So see if you can think of what your factors would be. They would be x plus 3 and then x minus 3. So those are the two shortcuts that we're going to talk about. What I would like for you to do now is to go ahead and look at A through F below and decide if it is a shortcut, yes or no, and if it is, which one is it? Is it an A equal to 1 shortcut, or is it difference of squares shortcut? Not all of these are shortcuts. You can go onto the website and check your answers on the calendar once you're finished to see if you understand, and then you can start on today's assignment.